Is there any questions from the audience here? Also.
I'm Gao Song from Artemia Association of China. Thank you very much to all specialists. You had given us a so interesting presentation tonight. I have two questions. The first question may to our good friend Thomas in the United States. So biosecurity is a very important issue in the hatcheries that we are using live food Artemia. Except for controlling the hatching of seeds and harvesting condition of monopoly in the hatcheries, are there any effective measures need to be conducted during dry seed processing to reduce the pathogen contamination? That's my first question. I have the second. My next question is maybe to Professor Gonzalo. Yeah. My second question is, we have a lot of parthenogenetic Artemia in China. Artemia in China. Do you expect that these are all different strains with different characteristics, or how similar may they be, especially when it comes to their application in aquaculture? Thank you. That's all my questions.
I'll ask Gilbert to go ahead and, forgive me, for Thomas to go ahead and answer the first question, please.
Sure. Yes, Gao Sung, very nice to see you again after all those years.
Yes.
Yeah, I'll try to answer that question as best as possible. What I can say is that I believe biosecurity actually starts with the actual resource. So, for example, I'll take the example of the Great Salt Lake in Utah. In Utah, around the Great Salt Lake, we actually do not have any marine fish culture, any shrimp culture. So we are already isolating and creating a biosecure environment, if you will. And I think that's where it starts. Obviously, the high salinities of our hypersaline systems help us with controlling some of the pathogens that we typically see in aquaculture. In terms of the processing itself, I believe that with the right disinfection during processing and with the right protocols in place, at least what we have seen is that we can actually process a cyst that does not contain either human pathogens or, for that matter, aquaculture pathogens. Specifically to our organization, in the last 16 years or so, we have not been able to detect any marine pathogen in our cysts. That being said, if you do all of those things correctly, there is still an issue of the actual hatching process in the hatchery, because a lot of the pathogens that we see in aquaculture are in the environment. And so what happens during the hatching process, I believe, is that a lot of organic matter is being released, and that creates a great environment for some of these R strategist type of bacteria that can then bloom and grow, and that can create a problem. The good news is that there are some new technologies today, some new coatings that are available that are actually suppress these bacteria to a level where they're not affecting our aquaculture species. And those technologies, I think, really help with those issues that we encounter in the hatcheries. With that, I hope that I've correctly answered your question.
Thank you, Thomas. I hope we could see in the future that's a concrete protocol that's controlling of biosecurity in the maybe the updates, the Artemia manual. Yeah, thank you, Thomas.
Welcome.
Thank you. For the second question, then I would like if Mr. Gonzalo, could you please answer that second question? Thank you.
Very, very good that you bring this problem up. I think my first reply to your question is that you could expect minor differences, but don't forget that the mitochondria in the Artemia can have different mutations. And since the mitochondria is the energy machinery of the Artemia, okay, any mutation can have a very important functional error, let's say that, in the transfer of electrons to provide energy. So I should say that now there is very good information that different parthenogenetic types can have differences and very useful, functional, or lethal, depending on the genes affected, on the phenotype of or the fitness of the animal. So a very simple question. Okay, you can don't see difference, but you need to try. And as Gilbert said, you need to discover these genes and what is the sequence they have to see if the protein they encode is affected. So what I suggest is that we need to do the characterization of the different parthenogenetic types. I hope I clarified this. Thank you.
Thank you. Thank you, Professor.
Thank you.
Hello, Rodrigo. I think so far it's the questions from China, from Shanghai.
Okay, very well. Thank you, Professor Ling Sui. As of that, I would like also to pose a question to the audience in Shanghai, if that's possible. Could you please direct these questions to the audience there? The questions goes like that. China is harvesting a lot of Artemia biomass from the coastal salt ponds. Does that not lower the production potential of cysts at these sites? Thank you.
Yes, I think I tried to answer the questions. Indeed, China has produced a lot of Artemia biomass, especially in coastal salt works. And I think to some extent, the cyst production could be improved by reducing the biomass harvest, but it won't be that very much because the farmers, they know when they should start harvesting the biomass and when they should stop to let the Artemia produce cysts. So, for example, in Bohai Bay, the biomass harvest starts from later April and early May. And then the biomass harvest will be reduced in June and also after mid of August when the Artemia turn into the oviparous production. So in fact, the farmers are able to balance the production of the cysts and the biomass according to the profit that they can make. So there is a balance according to farmers' judgment. Yes, Rodrigo.
Thank you. Thank you, Professor Ling Sui. Very clarifying. And I know that we are running a little bit over time here, but it's such an interesting topic and such a good discussion going on. I would like to at least try to address a couple of questions from our internet audience here. And one of those I would like to bring on is the one that Karen Viverica put regarding the current status of pilot Artemia production project in Africa. And he's speaking out specifically for Senegal and Kenya, but possibly other sites as well. And also there is someone else that rephrased that sent that question, asking what else is going on within the Africa continent towards Artemia development and what are the potentialities in there. So for that, I believe that our colleague Patrick Sogelos could give some perspective on that, what's going on there. Thank you, Patrick.
Yeah, thank you, Rodrigo. And good question indeed, because Africa has quite some potential. Already quite some years ago, 1985 or 86, if I remember well, there was a successful project of Artemia production in Kenya. Gilbert can explain about the follow-up, because apparently since a couple of years, there is quite some activity in relaunching, in reactivating that project with a number of small salt producers in the Malindi area. But we should also refer here to the work that was done in Mozambique a number of years ago. A pity enough that it has not been discontinued, that it has not been continued. The same in South Africa. The same, and I have seen that there was also a remark from Botswana. At a certain point of time, there was also an interest to see if some of the local salt farms inland, working with high salinity wells, could be used for Artemia production. So to conclude, Africa definitely has potential. There are some activities ongoing, but there is room for much more work in that continent. Gilbert, you have anything to add?
Well, no, I think that summarizes it very well, Patrick. Maybe in terms of the natural populations of Artemia, the extent to which they have been studied, that's very uneven. In South Africa, they have done a nice exercise. Also, North African countries, there's quite some literature on this. But let's say the rest of sub-Saharan Africa, there's just very scattered information on this. And indeed, probably, as Patrick was saying, the best example where people have taken up the technique of Artemia pond production in Africa is the Indian Ocean coast, a certain area of the Indian Ocean coast of Kenya. It has spilled over into Tanzania as well. Or, okay, there are independent developments in Tanzania, maybe inspired by the Kenyan exercise, but that part of the continent, there are activities ongoing. But definitely room for improvement, for expansion, etc.
Okay, thank you both. Really great to see that that's been made, that some progress can be made as well, and for other continents, and the potentialities there be assessed and move forward. I would like also to maybe one last question from our internet audience, and that's from our colleague here in Rome, Alessandro Lavatelli, which he put a question regarding the first question that Patrick did in his presentation. Will Artemia become a limiting factor in future aquaculture development? So he's pointing out that should we ask this question as we see the annual aquaculture development slowing down? Have we identified any alternative or developed an effective artificial alternative feed? I don't know if Patrick would like to answer that, or one of the other panelists, how they see this issue and how we should move forward. Thank you.
Well, maybe I can start and see who wants to join. I think we have seen over the years that the use of Artemia has become more and more efficient. Just to give you an example, in the early years, we needed 25 kilos of Artemia to produce 1 million post-larvae of pinnate shrimp. Today, we can do it with 3 kilograms. So one thing is we have learned how to bring in formulated feeds, how can be supplement, substitute, and eventually, but this is my whole career, that I heard that next year we will have a total replacement for Artemia. I think Artemia is such a unique source of live food as starter food, but that we should try to use it as efficient as possible. So with further expansion of aquaculture, okay, there might be need for more Artemia, but there might also be more opportunities to come with earlier replacements in the hatchery development.